Hello everybody, I am Syed Salimuddin, lecturer, Mechanical Engineering, Machine Tool Technology, SJ Government Polytechnic, Bangalore. Today I am going to present the topic of mandrels and operations performed in a lathe. Earlier we have discussed about the lathe accessories and attachments. Today we will discuss about mandrels. In this mandrels we have got plane and expansion mandrels. Then after this we will discuss about the operations performed in a lathe. What are the outcomes that we are going to learn today? Understanding the different accessories and attachments, this we have done in the earlier classes. Used for lathe. Here plane and expansion mandrel along with the operations performed in a lathe. Now very beginning we have studied the lathe accessories and attachments. So under these accessories we will first study what is a mandrel. A mandrel is a device used for holding and rotating a hollow piece of work that has been previously drilled or bored. Here the work revolves with the mandrel, which is mounted between the two centers, that is the live center and the dead center. The machining outer surface of the workpiece, that is concentric with the mandrel. Now to avoid the distortion and wear, this mandrel is made up of high carbon steel. The ends of the mandrel are slightly smaller in diameter and flattened to provide effective gripping surface of the lathe dog with the set screw. Then we have got different types of mandrels. So here I have listed. One is plain mandrel, step mandrel, collar mandrel, screwed mandrel, cone mandrel, gang mandrel and expansion mandrel. Now what is this plain mandrel? The plain mandrel is most commonly used in shops, and this finds a wide application where a large number of identical pieces have standard sizes. Holes are required to be mounted on it. Now this mandrel is slightly tapered. The tapered is usually about 1 mm to 2 mm difference in diameter for a length of 100 mm length. So this is provided for proper gripping of the workpiece. Now the mandrel rotates with the lathe dog and the lathe plate, and this drives the work by friction. Now the mandrel is suitable only to the size of the hole. You can see the sketch of a plain mandrel. Next is expansion mandrel. There are different types of expansion mandrels. The expansion mandrel which I have shown here it consists of a tapered pen. You can see from the sketch, which is driven into a sleeve. We have got a sleeve. Then that is parallel outside and tapered inside. This sleeve has 3 longitudinal slots, 2 of which are cut nearly through. You can see from the sketch, and the third splits it completely. To use this mandrel, the sleeves are first placed within the work with the pin removed. Then the pin is pressed from the end into the sleeve and the sleeve expands. So that's why it is called as expansion mandrel. And when it expands, it grips the work securely and accurately. So this is about the expansion mandrel. Then we'll discuss about what are the operations that has been performed in a lathe. So lathe operations are done in a lathe. In order to perform these different operations in a lathe, the workpiece must be held between the live center and the dead center, and this have been driven by carriers and catch plates, or on a mandrel, or by chuck plates, or by an angle plate. We have got a number of operations which can be performed in a lathe, which I have listed here 1 to 24. One is centering, turning, chamfering, facing, knurling, eccentric turning, polishing, grooving, spinning, spring winding, forming, drilling, reaming, filing, boring, counter boring, undercutting, parting off, grinding, milling, thread cutting, internal thread cutting, tapping and taper turning. So then we'll discuss what is this centering. Now it is the operation of producing conical hole at the ends of the workpiece to set the workpiece in center line, which is shown in the figure. You can see from the sketch, centering is done, chuck is at the left side, right side is the tailstock or the dead center, then in between we have got the job and a central drill and a drill chuck. So thereby we will do the centering operation. Why we are doing this? For producing the conical hole to the end of the workpiece, and these holes which have been conically drilled can be held between the live center and dead center, and then we can do the specific operation. Then is the turning. Then what is this turning? Again, the job is held between live center and dead center, same thing. Then it is the process of removing excess material from the workpiece to produce a cylindrical surface or a cone-shaped surface, which is shown in the figure. The various types of turning which we can do it here is straight turning, we can do rough turning, finish turning, shoulder turning. Now straight turning, here the work is turned straight, it is made to rotate about its lathe axis, and then the tool is fed parallel to the lathe axis. Rough turning, it is the process of removing excess material from the workpiece in a minimum time by applying high rate of feed and heavy depth of cut. Commonly for rough turning, the depth of cut is given. For depth of cut is less in rough turning, and RPM is also less. Whereas in finish turning, the RPM is more, the depth of cut is less. In rough turning and finish turning, you can see the difference in the sketch. Finish turning, it is the operation performed with high cutting speed, small feed and very small depth of cut to generate a smooth surface. Shoulder turning, here when a workpiece having different diameters is turned, the surface forming the step from one diameter to the other is called the shoulder, and machining this part of workpiece is called shoulder turning. We have got different types of shoulder which are shown in the sketch, like A, B, C and D. Chamfering, so it is the operation of beveling the extreme end of a workpiece. This is done. Why this is done means this is done to remove the burrs and to protect the end from the damage and to have a better look. It is done at an angle of 45 degrees. What is this facing? Facing is the operation of machining the ends of the workpiece to produce flat surface with the axis. It is used to cut the work to the required length. Here the tool is fed perpendicular to the axis of rotation of the workpiece. Knurling, it is the process of embossing a diamond-shaped pattern on the surface of the workpiece. The purpose of knurling is to provide an effective gripping. Then filing, this is an operation performed after turning. This is done in lathe to remove burrs, sharp corners, feed marks on a workpiece and to bring the workpiece to the required size. The operation consists of passing a flat for cut file single cut file over the workpiece and revolves at high speed. An eccentric turning, if a cylindrical workpiece has two separate axes of rotation, one being out of the center, and the workpiece is termed as eccentric turning of different surfaces of the workpiece. Then we have got polishing. Polishing is performed after filing to improve the surface quality of the finer grades of emery cloth. After filing, it gives very smooth, bright surface. And grooving. Grooving is reducing the diameter of the workpiece over a narrow surface. It is often done at the ends of the thread or adjusted to a shoulder to have a smaller length. So sketches have been given what is done with the help of a tool known as the grooving tool. Spinning, the process of forming a thin sheet of metal by revolving the job with high speed and then pressing it against the attached headstock spindle. A support is given there to the tailstock, then pressure is applied and the revolving sheet metal by a long round nose form supported on the special tool rest. The workpiece slowly acquires the shape of the formers. So spinning operation you can see from the sketch. We have got the sheet metal. Then spring winding, also of making coil spring and passing the wire around mandrel which revolves on a chuck or between the center. Forming. Forming can be done by using a forming tool. Then combining two feet, that is cross and longitudinal. Then tracing or copying a complete. Drilling. You are aware with drilling. It is the operation of producing a cylindrical hole in a workpiece by rotating the cutting edge of a cutter known as the drill or driller. Reaming. Reaming is the operation done after drilling operation. It is done for finishing and sizing the hole which has been earlierly or previously drilled or bored. The tool used is a reamer. It is made up of high speed steel which has got multiple cutting edges. So in the sketch you can see the drilling operation as well as the reaming operation. Then boring. Boring means it is the operation of enlarging and turning a hole produced by drilling by punching, casting and forging. Then counter boring. It is the operation of enlarging a hole to a certain distance from one end instead of enlarging the whole drilled surface. Then taper boring. It is the operation of producing conical surface in a pre-drilled hole. The principle of turning the taper hole is similar to the external taper turning. Then is undercutting. So this is similar to grooving operation which is performed inside a hole. The process of boring a groove or a large hole at a fixed distance from the end of a hole, that is similar to boring operation. Parting means cutting. Parting off operation is the operation of cutting a workpiece after it has been machined to the desired size and shape. Parting tool is fed into the groove until the work is cut off in two parts. We can see from this sketch parting off and tapping. What is this tapping? So tapping I have mentioned earlier. Tapping. It is the operation of cutting internal threads of small diameter using a multi-point cutting tool called the tap. The tap is also made up of HSS. And grinding. Grinding is the operation of removing metal in the form of minute chips and feeding the work against the rotating abrasive wheel known as the grinding wheel. Milling is a special operation done in a lathe. It is removing the metal by feeding the work against the rotating multi-point cutting edges known as the milling cutter. Thread cutting is also an operation performed in a lathe. It is the operation to produce a helical groove on a cylindrical or conical surface by feeding the tool longitudinal when the work is revolved between centers. Internal thread cutting. This is similar to external thread cutting. You will find the difference is only the tool used. This tool is similar to boring tool with cutting edges ground and the shape of the thread to be cut. You can see in the sketch number of taper turning operations. We have got facing, taper turning, counter turning, forearm turning. Then we have got cut off, cutting off, chamfering, boring, drilling, knurling, etc. etc. So I think you know some of all the operations which we have done. Now next we will come for some of the objective type questions. So here some objective questions are there. In dash turning, the workpiece has two separate axes of rotation. The options given are taper, eccentric, plane. Then dash is the most important operations in a lathe. Options are eccentric turning, chamfering, thread cutting. Next, dash is the process of embossing a diamond shaped pattern on the surface of a workpiece. Operations polishing, knurling. Options given are polishing, knurling, grooving. Dash is the operation of producing conical holes in workpieces. Options given are turning, facing, centering. Next, a dash mandrel is most commonly used in shops. Step mandrel, collar mandrel, plain mandrel. Next, a sleeve of an expansion mandrel has dash longitudinal slots. Options are 1, 2, 3. Seventh, dash is the operation of beveling the extreme end of a workpiece. Options chamfering, facing, turning. Eighth, dash is the operation of machining the end of a workpiece to produce a flat surface square with the axis. Options are chamfering, facing, beveling. Ninth, dash is the operation of removing metal by feeding the work against rotating cutter having multiple cutting edges. Options grinding, milling, shaping. Last one. Dash is the operation of enlarging a hole through a certain distance from one end instead of enlarging whole drilled surface. Options are boring, counter boring, taper boring. So key answers are given. You can check out this. So some assignment I have given. Then assignment questions. What is a mandrel? Sketch and explain a follower. Rest. So mandrel, you know, mandrel is a device which is used to turn a hollow piece of work. That is mandrel. And sketch and explain a follower rest. We have got two types of rest. One is study rest and the other is the follower rest. You can go through that and try to answer it. Then list the different operations performed in lathe. All the operations I have mentioned, you can go on listing it, and briefly one line I have given so that you can go through. Then what are the special operations performed in a lathe? You can do two special operations like grinding and milling in a lathe. Thank you.